All right, let's talk about molecules and ions. So, molecules, two or more atoms combined in set ratios. There are a couple molecules that are considered elements. These are the diatomics. There's 7 of them. You need to know these: hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine will always show up if you're talking about molecular oxygen, molecular hydrogen, molecular nitrogen. So if it's not in a compound, if we're talking about, oh, I reacted this with oxygen or I added chlorine gas to this, you're talking about a diatomic. So this comes into play if you're doing like combustion, which is basically adding oxygen to something. You're adding O2, not O. You're adding I2, not I. So if it's in a compound, then it's fine. But if it's by itself, if we're talking about the quote element, then it's going to be H2, O2, N2, F2, Cl2, Br2, I2. Okay, so those 7 molecules, as they naturally occur in nature, come as diatomics. There are some other ones like phosphorus is usually P4, sulfur is SA, that you probably don't need to know off the top of your head. These 7 you probably need to memorize. So we can differentiate between organic molecules, which don't have metals and generally have a lot of carbon, and inorganic molecules, which do have metals and they could contain carbon, but generally, so organic and inorganic doesn't necessarily have anything to do with life. It just has to do with metal versus non-metal. Ions are charged atoms or molecules. So you can have an atom, like a monoatomic ion, where it's just sodium by itself, or you can have a polyatomic ion. So remember, a cation is a positive charge. I lost an electron. An anion has a negative charge. I gained an electron. And cations and anions will combine to form ionic compounds, and they do so in such a way that the charge is balanced, which when we look at nomenclature, we'll go a little bit more, or chemical formulas, we'll go a little bit more into that. And then you can have polyatomic ions, which are basically covalent molecules that have a charge. So, for example, carbonate, that's carbon and oxygen, which are nonmetals, combined to form an ion. It has a 2- charge, right? So you can have polyatomic ions. So when we talk about chemical formulas, okay, a chemical formula is basically a whole number ratio of elements. And we can talk about covalent or molecular compounds, which are combinations of nonmetals like water, carbon dioxide, glucose. These are all made of nonmetals and nonmetals, right? And we can talk about ionic compounds, which are combinations of metals and nonmetals. Now, when we use the term salt, we're not necessarily talking about table salt, although we could be talking about that. A salt just means a metal plus a nonmetal. An ionic compound is considered a salt in chemistry. Aluminum oxide, magnesium hydroxide, these are all ionic compounds. You have metals plus nonmetals. So we can separate our chemical formulas into molecular versus empirical formulas. So a molecular formula is basically telling you here are the atoms in the molecule. So we look at these compounds: H2O, C6H12O6, which is glucose, N2O4, H2SO4. That's telling you that in that molecule, there's 2 hydrogens and 1 oxygen. In one molecule of glucose, there's 6 carbons, 12 hydrogens, and 6 oxygens. Okay? An empirical formula is giving you the smallest whole number ratio. Okay? So it's saying for every X, you have Y. And all ionic formulas are empirical. Now, you might notice H2O can be both a molecular formula and an empirical formula, because the molecular formula is saying in this molecule I have 2 hydrogens and 1 oxygen. That's what's in the molecule. The empirical formula is saying for every 2 hydrogens I have 1 oxygen. Okay? If we look at the glucose, right, there's 6 carbons to 12 hydrogens to 6 oxygens, right? Well, I can divide all those numbers by 6 and I get 1 to 2 to 1. So the empirical formula would be CH2O, 1 carbon to 2 hydrogens to 1 oxygen. Sodium chloride, and every single ionic formula is empirical. It's saying that for every 1 sodium, I have 1 chlorine, right? Because salts end up forming really large crystal structures. So to say you have a molecule of salt doesn't really mean anything, because you're always going to have a large crystal structure that has a ratio of 1 sodium to 1 chlorine. So the relationship between the molecular and empirical formulas is that the molecular formula is a whole number multiplied by an empirical formula. Now, in the case of water, the whole number is 1. 1 times the empirical formula of water is H2O, which is the molecular formula of water. But for something like glucose, it's 6 times the empirical formula of CH2O. So that's the relationship between the molecular and the empirical formula. So to reiterate one last time, the molecular formula tells you there are exactly these atoms in this molecule. The empirical formula tells you this is the ratio of molecules, and you always simplify as much as possible. So you don't say it's 2 to 2 to 2, you would say it's 1 to 1 to 1.